Hi, my name is Ed Kolodka. I'm one of the lab instructors, and I'll be showing you around one of our undergraduate teaching labs. This is Harrington Hall 321. It's one of our larger undergraduate teaching labs. If you'll follow me. This is Dave Hirschman. He is our lab tech amongst many other jobs and roles, and he'll be showing you around and showing you some of the safety features we have in this lab.
Thank you. Well, welcome again. First, we'll talk a little bit about the safety glasses. Again, you will notice that our container is empty, and due to COVID, we're issuing the students instead of grab and go, so they're sealed up brand new to the student when they get them, and I have extra in case of loss, damage, forgot, or whatever, so they're always protected because PPE is mandatory in all of our labs. Okay? Fire extinguisher, as is a fire blanket. Okay? And being this is one of our larger one, I have another empty safety glass cabinet. Material safety data sheets. Our first aid kit. Also, if you want to back up for a sec, we do have spill kits available in all our labs in the event of, and they're all pre-packaged, ready to go for the stuff that's in here. The room is ventilated, but also we have several fume hoods in here. Here's one of the smaller ones, okay? And the students are briefed on this prior to use. All of our students, before they come into the lab, are given a safety lecture, and they are quizzed on the contents of that. And then when we get them in here the first time, we do a little bit of familiarization, pointing out where the safety equipment is. Fire extinguishers, okay, emergency eye wash stations, and located right outside the door is a body wash station, centrally located. And I'm going to touch on the ice machine. Normally you wouldn't think of that as something safety related, but being this is in a laboratory environment, the ice in here is not considered food safe, so that's why it has a sign on it, and we do brief all the students that come in here not to use this to chill their pop or water or whatever else. It's not considered food safe because it's in a lab environment. The other piece of equipment in here that I'm going to talk to a little bit is our drying oven. They have the potential to ignite, so we do teach the kids and remind them of proper operation, setting their set points, making sure the fume hoods are on because this is vented to the ventilation system for whatever you're trying to off gas in here, and there's a log that they have to fill out so we know what's going on in here. Also, we have bottled gases in this laboratory. As you notice, they're all chained up per OSHA, safety, and the gases that we have in here are CO2, nitrogen. I don't know if you can see, but behind I have an oxygen bottle that we use to fuel the calorimeter. Also in here is our chemical waste storage area. Some of the things that are generated in our labs are not good for the environment, and you can't dispose of them down the drain, so we collect them and then we turn them in as hazardous material or waste or whatever the case may be for whatever it is that they made. Next to it here, we have a flammable storage locker. Some of our bulk chemicals are in here. My extra acetone, for instance, is stored in here because it is flammable. All the students know where this is, and they're to get it and then put it back in here again. They're briefed in our lecture about the use and the proper operation of these cabinets. And a little bit about COVID. We talked a little bit about with our glasses, but we still have our plexiglass dividers up defining each one of the lab space. And also you will see behind me here are some bigger room dividers, and these would actually go right down the center of this lab when we're in operation. We just have removed them today for the ease of filming and so we can explain how this lab works. One of the last things, okay, again you will see we've got a couple more cylinders here, they're chained up. We also have our scales or balances, whatever you prefer to call them, in here. They are certified by an outside company a couple times a year and cleaned and make sure they're all calibrated correctly so the stuff that the students are weighing is accurate. Last, you will notice that we're not wearing safety masks or whatever. They are required when our students are in labs to wear the mask for protection, but we have elected to remove them today because our labs are not in session, and it's a lot easier for us to enunciate and you can be able to understand us better instead of all our voices being muffled. So that's why you don't see masks on us today. And with that, I will turn this back over to Dr. Kalatka.
Hi, I'm going to take a couple of minutes and talk to you about some of the labs that we do in this lab. So in 321, students that work in here range from sophomore up to the senior level. We have 4 lab classes and they all use this lab. First experiment I'd like to touch on is a reverse osmosis instrument. So with this unit, what we have the students do is mix a variety of salt water solutions at various concentrations, pass it through it, and then using some mathematical techniques, they need to estimate what the pressure drop is across the membrane without being able to measure it. Let me take you to the next experiment. Over here we have a fluidized bed, and the way we've put together this fluidized bed, this is a homemade project. So what we have here is water that recirculates through this column, and within the column the students will place a number of different objects so that they can study fluidization and look at what factors determine fluidization. Take you to another experiment. This is at the sophomore level, and what the students do with this experiment is it's just a cylinder, pressurized cylinder, and what they'll do is put a variety of gases into this cylinder at different pressures. They will have a known amount, they'll be able to weigh the amount of gas present in the cylinder, and they will need to predict what the non-ideal properties of the gas are. Gases are. Next experiment I'd like to show you and give you a little feel for this is we have a number of experiments that are boxed up, and this is just an example of one of our boxed up experiments which we bring in as required. And what students do with this experiment is they are able to study the viscosity characteristics of guar gum, which is used in fracking. And so the students will mix up a variety of guar gum solutions, and they'll measure the viscosity characteristics of those solutions using a falling ball viscometer. This is at the sophomore level, and it's oftentimes students' first experience with non-Newtonian fluids. If you'll follow me, I'm trying to remember what my next station is. You'll follow me over here. This is another one of our boxed experiments, again an example. And what this is a viscometer. And with this instrument, what students are doing is they use it to characterize the viscosity of a number of solutions and pure substances. And they'll look at this over a range of temperatures. And the last instrument I'd like to talk to you about is our calorimeter. So students use this calorimeter in order to estimate heats of reaction, primarily combustion reactions. And so they look at what's the heat of reaction for graphite, and we use that for them to determine whether what the purity is of the graphite samples. That concludes that concludes our tour of Harrington Hall 321. Thank you.